Alright, let's go. Number 10, the arrow of time paradox. The fundamental laws of physics, the equations that govern every particle, every force, every interaction in the universe, work exactly the same whether time flows forward or backward. Run the math in reverse, and nothing breaks. A shattered teacup could mathematically reassemble itself from fragments scattered across the floor, the porcelain shards rising, fusing, the tea pouring back into its restored vessel as if a film were running in reverse. The equations permit this. Physics has no objection. And yet, in the entire history of human observation, in every laboratory experiment ever conducted, in every moment of every life ever lived, no one has ever witnessed time flowing backward, not once. The universe enforces a single direction with absolute, unbreakable consistency, but science cannot explain why. The accepted answer involves entropy, the measure of disorder in any system. Entropy always increases. Hot coffee cools, mountains erode, stars burn out, bodies decay. This is called the second law of thermodynamics, and it points time's arrow forward with relentless precision. But here's where the nightmare begins. Entropy only increases because the universe began in a state of extraordinarily low entropy, an arrangement so improbable, so finely ordered, that physicists like Nobel laureate Roger Penrose have spent decades trying to explain how it could have happened at all. Penrose called it the whale curvature hypothesis, and it remains unresolved. The universe started organized for no known reason, and every moment since has been a slow slide toward disorder. What this means for you is unsettling in a way that's easy to miss. Every breath you take, every heartbeat, every thought firing across your neurons is part of a one-way journey toward decay that physics fundamentally cannot justify. The arrow points in a direction the equations don't require. Your aging is mandated by an initial condition no one can explain. The tick of entropy is silent, but it is absolute. You are riding a wave that should not exist toward an end that the universe has no reason to enforce, and yet does. Every cell in your body knows which way the arrow points. Science does not know why. Number 9, time slows down near massive objects. In 1915, Albert Einstein completed his general theory of relativity, and in doing so, he destroyed one of humanity's most cherished assumptions. Time, he proved, is not a constant. It is not a universal river flowing at the same speed for everyone, everywhere. Gravity warps it, mass bends it. The more massive an object, the more it stretches and slows the passage of time around itself. This was not a thought experiment. It was a measurable, testable reality, and every modern test has confirmed it. The GPS satellites orbiting Earth right now must adjust their internal clocks by exactly 38 microseconds per day, or the entire system would fail within hours. The satellites experience time slightly faster than we do at the surface because they sit higher up Earth's gravitational well. Without this correction, your phone's navigation would drift miles off course within a single day. Time itself is being actively compensated for every second by every device you own that talks to a satellite. The effects scale with gravity. A clock at sea level ticks measurably slower than a clock on a mountaintop. The difference is tiny, nanoseconds, but it accumulates. Your head, sitting slightly farther from Earth's center than your feet, is aging faster than your lower body. Right now. As you listen to this. The aging is microscopic, but it is real and it is constant. Near a black hole, the effect becomes catastrophic. To an outside observer watching someone fall toward the event horizon, time slows so dramatically that the falling figure appears to freeze, suspended forever at the edge of the abyss, light from their final moments stretched and reddened until it vanishes entirely. For the person falling, time runs normally, but the universe around them speeds up, galaxies aging in moments, stars being born and dying in the time it takes to blink. There is no universal now. There is no shared present moment connecting all of reality. Every object in the universe experiences its own private clock, running at its own private speed, determined by where it sits in the warped geometry of space-time. Your now is not your neighbor's now. Your now is not the now of a satellite or a mountain climber or a passenger on a plane. The moment you call the present is a personal illusion, a local approximation of a phenomenon that has no global meaning. Time is not what you think it is. It never was. Number 8, the quantum time problem. Physics has two great pillars, each describing a different scale of reality with extraordinary precision. General relativity governs the large, planets, stars, galaxies, the curvature of space-time itself. Quantum mechanics governs the small, particles, fields, the strange probabilistic behavior of matter at its most fundamental level. Both theories have been tested to extraordinary precision. Both work flawlessly within their domains, and they are completely mathematically, irreconcilably incompatible when it comes to time. In general relativity, time is flexible, warped, woven into the fabric of space-time as a fourth dimension that bends and stretches with gravity. In quantum mechanics, time is something else entirely. It is treated as a background parameter, a fixed external clock against which quantum events occur. It is not warped, not flexible, not part of the system being described. Time in quantum mechanics is essentially assumed rather than explained. When physicists try to combine these two frameworks into a single theory of quantum gravity, the equations produce something deeply unsettling. The Wheeler-DeWitt equation, derived in 1967, attempts to describe the quantum state of the entire universe, and when you write it out, time disappears. The equation contains no time variable at all. According to one of the most rigorous attempts to unify physics, time may simply not exist at the deepest level of reality. Quantum particles behave in ways that seem to mock the very concept of temporal flow. Entangled particles appear to coordinate their states across vast distances instantly, as if the future and the past were communicating through a hidden channel. Measurement outcomes seem to depend on observations that haven't happened yet. Particles appear to know things they couldn't possibly know in a universe where time flows forward in the way we experience it. What this means is that the time you feel passing, the steady, irreversible tick of moments accumulating into hours and years, may be an emergent illusion, a property that only appears at large scales, woven together from a substrate where time has no meaning. Beneath the world you perceive, there may be no past, no future, no flow, just a timeless quantum foam from which the appearance of temporal experience somehow arises. You may be living inside an illusion built on top of a reality where the very idea of living has no foundation. Number 7. The Mandela effect. In 2010, a paranormal researcher named Fiona Broom was at a conference when she discovered something strange. She remembered vividly and with absolute certainty that Nelson Mandela had died in prison in the 1980s. She remembered the news coverage, the funeral, the speeches, and she was not alone. Thousands of other people remembered the same event, with the same details, the same emotional weight, the same certainty. But Nelson Mandela had not died in prison. He had been released in 1990, served as president of South Africa, and lived until 2013. The memories were impossibly wrong, and they were impossibly consistent. This phenomenon, now called the Mandela effect, has been documented across thousands of cases. Large groups of people share identical false memories of events that never happened, products that were never named the way they remember, lines from films that were never spoken, geographic locations that have never existed in the places they recall. The memories are not vague. They are vivid, detailed, emotionally anchored. People can describe textures, colors, sounds, and they are wrong. Mainstream science attributes the Mandela effect to confabulation, the brain's tendency to construct false memories from fragments of related information. The explanation is plausible, even likely, but it does not account for the consistency. When thousands of people independently confabulate the exact same false memory with the exact same details, something stranger than ordinary memory error appears to be happening. Some physicists working at the speculative edge of multiverse theory have suggested that the Mandela effect might represent traces of parallel timeline bleed-through, memories from versions of reality, where events unfolded differently, somehow leaking into this one. The mainstream explanation is almost certainly correct. Your memory is far more fragile, far more reconstructive, far more unreliable than you want to believe. Every memory you have ever recalled was rebuilt from scratch in the moment of recall, edited, contaminated, and stored again with the edits intact. Your childhood is a series of approximations. Your past is a draft. But if even that explanation is true, the implication is just as disturbing as the alternative. You do not remember your life. You remember the most recent version of a story you have been quietly rewriting for decades. Either your timeline is unstable, or you are. Number 6. Closed timelike curves. In 1949, the mathematician Kurt Gödel, a close friend of Einstein, presented him with a birthday gift. It was a solution to the equations of general relativity describing a universe that rotated as a whole. Within this rotating universe, Gödel proved, there existed paths through space-time that looped back on themselves. A traveler following such a path would move forward through time, always forward, and eventually arrive at their own past. Einstein examined the solution and admitted he was troubled by it. The equations permitted time travel. There was nothing in the laws of physics that forbade it. These paths are called closed time-like curves, and they remain a legitimate solution to Einstein's field equations to this day. No physical law currently rules them out. They appear in solutions involving rotating black holes, traversable wormholes, and various other exotic spacetime configurations. The mathematics says they are possible. The mathematics says you could, in principle, walk in a straight line through spacetime and arrive at yesterday. This creates the grandfather paradox. If you could travel to the past, you could alter events that led to your own existence. You could prevent your grandfather from meeting your grandmother. You could prevent your own birth. And if you were never born, you could not have traveled to the past to prevent it. The logical contradiction is total. The universe should not allow it, and yet the equations do not forbid it. Physicists have proposed various resolutions. Stephen Hawking suggested a chronology protection conjecture, an as yet undiscovered law of physics that prevents closed timelike curves from forming. Others have proposed that any attempt to create a paradox would be self-correcting, that the universe would conspire to prevent contradictions through coincidence and circumstance. Some suggest that time travel would simply spawn a new timeline, leaving the original untouched. None of these proposals have any experimental support. They are guesses. Educated guesses, but guesses. The honest answer is that physics permits something that should not be possible, and we do not know what stops it. We do not know if anything stops it. Somewhere in the geometry of spacetime, there may be paths leading backward. Somewhere, in some configuration of matter and gravity, the past may be reachable. And if it is, the question is not whether someone will eventually walk one of those paths. The question is whether someone already has. Number 5. The specious present. You believe you are experiencing this moment as it happens. You believe the sound of these words is reaching you in real time, that your awareness of your surroundings is current, that the now you inhabit is genuinely now. Neuroscience has spent decades dismantling this belief, and the conclusions are unambiguous. You are not living in the present. You have never lived in the present. You cannot live in the present. Your brain will not allow it. The phenomenon is called the specious present, and it works like this. Different senses arrive at your brain at different speeds. Light travels faster than sound. Touch signals from your feet take longer to reach your brain than touch signals from your face. Visual processing requires more time than auditory processing. If your brain presented each sensory input the instant it arrived, your experience of the world would be a chaotic, fragmented mess of staggered signals. Instead, the brain waits. It collects signals, holds them in a buffer, and assembles them into a unified experience of a single coherent moment. This assembly process takes between 80 and 400 milliseconds. The moment you call now is actually a memory of events that happened. Up to nearly half a second ago. The snap of your fingers reaches your awareness after the snap has already ended. The face of the person speaking to you is a face from a fraction of a second ago, stitched together with audio from a slightly different fraction of a second ago, presented to your consciousness as a single integrated present that does not exist anywhere in physical reality. What this means is staggering. The present moment, the thing you have always believed to be the most immediate and undeniable feature of your experience, is a construction. A hallucination, a user interface generated by your brain to give you the illusion of being in time. You have never seen the world as it is. You have only ever seen the world as it was, processed, edited, and presented to you on a delay. And science cannot explain how this assembly happens. The mechanism by which the brain binds together disparate sensory streams into a unified conscious experience remains one of the deepest unsolved problems in neuroscience. It has a name: the binding problem. It has no solution. You are living inside a moment that your brain manufactures from scratch, dozens of times per second, using methods nobody understands. The now you inhabit is a fiction, and it is the only now you will ever have. Number 4. Time dilation in astronaut twins. In 2015, NASA began an unprecedented experiment. Astronaut Scott Kelly spent 340 consecutive days aboard the International Space Station, orbiting Earth at roughly 17,500 miles per hour. His identical twin brother, Mark Kelly, also a former astronaut, remained on the ground. When Scott returned, NASA conducted a comprehensive comparison of the twins. They wanted to know what nearly a year in space had done to a human body. What they found was both expected and deeply strange. Scott Kelly came back measurably younger than his brother. Not in appearance, in actual elapsed time. The relativistic effects of his orbital velocity meant that Scott had aged about 5 milliseconds less than Mark during the mission. The difference is small, but it is real, it is permanent, and it is precisely what Einstein's equations predicted. The twin paradox, long a thought experiment used to teach relativity, had been demonstrated on actual human twins. But the time dilation was not the strangest finding. When NASA examined Scott's body at the cellular level, they found changes nobody had predicted. His telomeres, the protective caps on the ends of his chromosomes, had lengthened during the mission, the opposite of normal aging. His gene expression had shifted in over 7% of measured cases, with many of the changes persisting months after his return. His gut bacteria had transformed. His cognitive performance had altered. The structure of his eyes had changed. Some of these changes reversed within months. Others did not. Some have not been fully explained to this day. The implications extend far beyond two brothers. If short-term spaceflight produces measurable temporal and biological divergence between identical humans, then sustained high-velocity travel would produce dramatic ones. A crew sent to a nearby star at relativistic speeds would return to find their families dead, their cities transformed, their planet centuries older than they were. The technology is not yet possible. The physics is unambiguous. Travel fast enough or far enough, and you will literally outlive the people you left behind. Not because they die naturally while you survive, because time itself moves differently for you than it does for them. You return to a world that has run ahead of you. Everyone you loved has been waiting for years that you did not experience, and there is no way to give those years back. Number 3, time crystals. In 2012, the Nobel Prize-winning physicist Frank Wilczek proposed something so strange that most physicists initially dismissed it as impossible. He suggested that just as ordinary crystals like salt and quartz break the symmetry of space by arranging their atoms in repeating patterns, there might exist a form of matter that breaks the symmetry of time by oscillating in repeating patterns. He called them time crystals. The catch was that these structures would have to move perpetually, ticking forever, without consuming any energy. This appeared to violate the fundamental principles of thermodynamics. It looked like perpetual motion. It looked like something the universe should not permit. In 2016, researchers actually created them. Teams at the University of Maryland and Harvard, using carefully prepared chains of ytterbium ions and nitrogen vacancy centers in diamond, observed structures that oscillated in stable, periodic patterns without absorbing or releasing energy. The time crystals existed in a state of non-equilibrium that classical thermodynamics said could not exist. They ticked. They did not run down. They simply continued. What this means is genuinely difficult to absorb. A form of matter has been confirmed to exist that moves through time the way ordinary crystals extend through space. It does not age. It does not decay. It does not run out. Within the boundaries of its quantum state, it pulses eternally, a shimmering lattice of atoms ticking like a heartbeat that never tires, indifferent to the second law of thermodynamics that governs the rest of the universe. Physicists are still debating what this discovery means. Some argue that time crystals do not truly violate thermodynamics, that they exist in a special regime where the usual rules do not strictly apply. Others argue that they represent a fundamental new phase of matter, as significant as the discovery of solids, liquids, and gases. The debate continues. The crystals continue to tick. And somewhere in the deepest implications of this discovery is a question nobody has answered. If matter can be arranged into structures that experience time differently than everything else, what else might be possible? What other forms of existence might be permitted by the laws of physics, structures that move through time in ways we cannot recognize, persisting without aging, present in ways our chemistry cannot detect? Number 2, the block universe theory. Einstein's special relativity, formulated in 1905, contained an implication so disturbing that many physicists have spent careers trying to escape it. The theory proved that simultaneity is relative. Two events that appear simultaneous to one observer may appear sequential to another, depending on their relative motion. There is no universal present moment shared across the cosmos, and when you follow this conclusion to its logical end, you arrive at the block universe. In the block universe, time is not a flowing river. It is a dimension, like the 3 dimensions of space. Past, present, and future all exist simultaneously, frozen into a 4-dimensional structure that contains every moment that has ever been or ever will be. Your birth, your death, every breath in between, all of it exists right now, equally real, equally permanent, embedded in the geometry of space-time like slices of bread baked into a single loaf. You experience these moments sequentially because your consciousness moves through them, but the moments themselves are eternal. They do not come into being. They do not pass away. They are. Einstein himself appeared to accept this view. When his lifelong friend Michel Besso died, Einstein wrote to Besso's family that the distinction between past, present, and future was, in his words, only a stubbornly persistent illusion. Many modern physicists agree. The mathematics of relativity does not describe a universe where the future is open and the past is fixed. It describes a universe where both are equally real and equally inaccessible to direct observation, separated from the present only by the limits of your perspective. The implications for free will are devastating. If every moment of your life already exists, fully formed, in the block of space-time, then your future choices are not choices in any meaningful sense. They have already happened. They are already there. The decision you believe you are about to make has been waiting for you in the geometry of reality since the universe began. You do not move through time. Time does not move at all. You are a thread woven into a four-dimensional tapestry, and every knot in that thread, every triumph, every tragedy, every quiet moment, every final breath, is already tied. You are reading these words because you are always going to read them. You will close your eyes for the last time because that closing already exists. The block is complete. Nothing in it can change. Number 1, the origin of time itself. Every disturbing fact about time, considered so far, depends on time existing in the first place. Time slows, time bends, time may not flow, time may already be complete, but all of these properties assume there is a thing, called time, to have properties at all. The deepest question is older and worse. Where did time come from? What existed before it? And the honest answer from modern physics is that the question may have no meaning. Stephen Hawking, working with James Hartle in the 1980s, proposed that asking what happened before the Big Bang is like asking what lies north of the North Pole. The question is grammatically coherent but physically empty. Time itself, in Hawking's view, began at the Big Bang. There was no before. There was no era of waiting, no primordial darkness, no silent expanse out of which the universe emerged. Time started, and with it, the very concept of starting started. This is almost impossible for the human mind to absorb. Your cognition is built around causality. Every event has a cause. Every effect follows from something prior. The idea that time itself has an origin, that there was no prior moment from which it emerged, contradicts the most basic assumption your brain uses to make sense of reality. And yet the alternative is no better. If time extended infinitely into the past, then an infinite amount of time would have had to pass before this moment could occur, and an infinite amount of time cannot pass. Either time had a beginning that violates causality, or it has no beginning at all and violates logic. Some recent theories suggest something even stranger. That time is not fundamental, but emergent. That it arises from quantum entanglement between particles, that what we experience as the flow of time is actually a side effect of correlations between systems too complex to track individually. In this view, time is not the stage on which the universe performs. It is a shadow cast by the universe's deeper structure, a useful approximation that breaks down when you look too closely. The Planck epoch, the first 10 to the negative 43rd seconds after the Big Bang, lies forever beyond our ability to investigate. The known laws of physics break down. Quantum gravity takes over, and we do not have a working theory of quantum gravity. The origin of time is permanently shielded from us by the limits of what physics can describe. Something happened, or something didn't happen, and the universe is here anyway. Either answer is incomprehensible. The very thing that allows you to read this sentence, to follow it from beginning to end, to experience the rise and fall of its rhythm, has an origin nobody can explain. And it is possible, genuinely possible, that no explanation can exist. That the question of why time exists is not unanswered, but unanswerable. You are riding a phenomenon that began for no reason out of nothing, carrying you forward at a speed you cannot measure toward an end that is already written into the geometry of a reality you cannot see. The clock ticks, the arrow flies, and the universe offers no account of where any of it came from. If you want to see more videos like this, click the video on screen now and make sure to subscribe.